So we'll start line integral today. Uh, in line integral, first of all, integration a to b f of x dx, this type of definite integration, you know how to solve this type of different integration. So what does it represent actually? It represents the area, you can say in a line that the area under this curve y is equal to f of x on x-axis. So it is, we are integrating with respect to x from a to b f of x dx. So what actually, what is this formulation? If you just recall, I think you have done familiar with this. Let me recall once again that suppose this is your x-axis, this is your y-axis, and let me write this curve y is equal to f of x. So suppose this is the curve y is equal to f of x. This is the curve y is equal to f of x, and we have x is equal to a somewhere at here, and x is equal to b somewhere at here. Then by means of this integration I, we geometrically we represent the area under this curve. This area we represent, that we know. How, and how could we express this integration as a summation form? That if we consider over this x-axis, now see, actually we are integrating over this x-axis, where integration range is from x equal to a to b. So now if I divide this interval range ab in like this, suppose if I consider a is equal to x0, then some points we represent like this, x0, x1, less x2, x3 up to xn, that equal to, we suppose b if I consider. So we are subdividing this interval in some finite number of parts like this. Not necessarily this length of the interval will be equal. It's not required that the length will be equal. Like this we are dividing. So if I consider the interval, this is suppose, so this is your x0, x equal to a, then x1, then x2, like this it is going. So suppose if I represent delta r, the rth interval, as xr minus 1 xr, suppose this one is your xr minus 1, and this is your xr, this interval, suppose if we select, then we choose a number xi r which belongs to this delta r. So here I am writing, I am choosing a xi r somewhere in between this xr minus 1 to xr. This is your xi r, this is your xi r. Then this value will be your f of xi r, this value will be your f of xi r. Now Now I'm writing delta, small delta r is equal to the length of the interval as xr minus xr minus 1. This is the length of the interval delta r. That means this length is delta r. Okay. So if this interval capital delta r is very small, then you can consider this length as equal, more or less equal to this small delta r, this length also. And in that case, we write this area of this rectangle, as f of xi r into delta r, f of xi r into delta r. And if we sum up all such intervals, r is equal to 1 to n, how many intervals are there? If we consider n plus 1 number of points, then we will be having n number of intervals, so r is equal to 1 to n, and delta r, and we select small delta is equal to maximum of this delta 1, delta 2, delta 3 up to delta r, the maximum value of this delta 1, delta 2, delta 3, delta r. If we select like this and we take the limit, and if here we take the limit, delta tends to 0, delta tends to 0 means this interval length is very close to 0. that means this n will be tending to infinity. In that case, this summation is denoted as the integration a to b f of x dx. Yes, that you know. This definition of integration, I think you have already crossed out. Okay, so this is the definition of this a to b f of x dx. So this is one particular case of line integration. Now, what do you mean by line integration? So what we are doing here, so now what actually we are doing here in this integration, which whatever we know, that I is equal to integration a to b f of x dx. So we're integrating from a to b on x axis. Now we replace, if we replace this a to b by a suitable curve some c, and suppose we have a two-dimensional function of several variables f of xy, or maybe sometime uh, xyz also. In that case, I will write this here later. First, suppose, so what actually we are here, suppose this is your z axis, this is your z axis, this is your y axis, this is your x axis. I am considering a three-dimensional case. This is our z axis. Now previously what we are doing, we are integrating along this line, now this along this line, x equal to a to b like this, or y is equal to a to b like this, or z is equal to a to b like this. So and now we are integrating along a curve. Suppose there is a curve in xy plane like this, there is a curve in xy plane like this, this is the curve c. So what you need to do, you have to integrate along this curve, not along this x-axis or etc. So we will integrate along this curve. Now this curve, you can represent any curve in parametric form sometimes, or maybe in Cartesian form. So suppose if you represent in parametric form, so suppose x is equal to x of t, t is a parameter, and y is equal to y of t. I can always represent a where this t value belongs from, runs from a to b. We can write any curve in this parametric representation. Suppose this is the curve c, this is the curve c. So what we do here, we will subdivide this curve, into some binary number point. So suppose this is the starting point p0. Suppose this is the starting point p0. Then I am taking here another point p1. Then I am taking here another point p2. Then I am taking here another point p3. Then p4. Like this, we are taking some points on this curve. Now, what is your f of xy? Is a function from a function of two variable x and y. So if I write f of xy, if we plot z is equal to f of xy, what will represent this? This will represent a surface in three-dimensional space. So suppose the surface is like this. Suppose a surface is like this in three-dimensional space. Suppose this is your z is equal to f of xy. Suppose this is your z is equal to f of xy. Now this is a surface of any type. You can consider like that roof of something, so is bending roof like this. So this is a surface. Now you see this if you project each point, so here you see p0 will be a point that will be the coordinate of this point will be some x0 y0, then p1 that will be some x1 y1, then p2 that will be some x2 y2, like this. So for this each p0 p1 p2, you can find from here z is some z0 z1 like this. So some point always you can project
Sir,
here.
excuse me, sir.
So suppose this is your P0.
Sir,
हाँ बोलो
ये sir, the
बोलो.
z axis should be that negative z axis, because cross product of x and y axis should be in the downward side.
That you can orientation you can forget now. Orientation whatever you do, you can write into a lower direction. And suppose I'm just making the
Okay,
orientation
sir.
like
Okay,
this.
sir.
No issue. No issue. So P0 will be suppose somewhere 0 dash here. Then P1 you can plot somewhere at here. Then P2 like this. P3 like here. So you will get some another curve over here. Okay. Then so what actually P1 minus P0, this distance actually represents what? Suppose I am writing delta SR is equal to this point P2 distance. This delta S are actually I am writing this length, this arc length of this P0 P1. Okay, distance from P0 P1, not write P1 minus P0. You write that this is the distance from P1 minus P0 along the curve. Distance means the curve length. Okay, not the straight line distance. This is the curve. This arc length I am writing. Delta SR you can consider as the arc length. Suppose this is your if I write here S0, S1, S2 like this. So delta SR is equal to SR minus SR minus 1. This is the delta SR. And if I consider delta is equal to the maximum of this curve length S0, S1, mm, delta S1, delta S2 like this, if I consider the maximum of this, then here we define f of, suppose some xi point will be here, some xi point will be here. So this f of xi is where? Xi is a point in between P0 minus P0 and P1, some point. F of xi into delta SR, and here you take summation delta tends to 0, and limit, sorry, you take summation is equal to from r is equal to 1 to n, and limit delta tends to 0. This actually represent what? Xi actually, xi is a point xr yr, some point. So this will be integration a to b, integration over c along this curve c. Integrand is f of xy, integrating with respect to s, the arc length. Now you see, if you project this curve, on x-axis, if you are able to project this curve on x-axis, so actually by means of this integration over c f of xy ds means the area of this surface, understand, this surface, the area of this surface representing by this line integration. Now if you project this on x-axis, and if this curve will be shifted over here accordingly, then whatever the things we will get, that sometimes ds may be changed as dx, maybe sometimes dy, maybe sometimes ds. That's why here in the first slide I've written here this over c fds, sometimes it will be given, I will be discussing when with some problem. Sometimes c f of x f dx, sometimes c f dy, sometimes c f dz. This means what? Here if I write if I consider this one, this is mean integrating along the curve c with respect to s, the arc length of the function f. This means integrating with respect to x along the curve C, the function f. This means integrating with respect to y along the curve C of f, and integrating with respect to with respect to z along the curve C of the function f of xy. So how to now how to find the values? So let me now take evaluation of this line integral. How to evaluate the line integral? Suppose you are asked to evaluate this integration c f dx plus g dy like this. Problem will be given like this. Some integration, and this c curve will be given. This c curve will be given to you. Suppose case 1, if I consider, this c curve is given as some y is equal to 5x. Suppose this c curve is given y is equal to 5x, and x is from a less than equal to x less than equal to b. So what is this curve is given from x is equal to a to x is equal to b, y is equal to 5x. Suppose this is the curve. So you have to integrate x axis, this is y axis. You have to integrate along this curve C. You have to not along this. You have to integrate along this curve C. Along this curve C. And what you have to integrate? You have to integrate this function f and g. You have to integrate this function f and g. So f g are function of some xy. So it will be, if you can consider some z axis over here, and here it will be, we will be having a surface. So if the case is like this, problem will be not be so complicated. So if so y is equal to f of x is the given curve, what you will do? You simply write y is equal to phi of x. You put y is equal to phi of x over here, whatever we have, and take the limit x is equal to a to b. So you can write this is as integration a to b f dx plus g dy is equal to integration a to b f of x comma phi x dx plus g of x comma phi x, sorry, not phi x, yes, phi x into phi dash x dx. So you have to integrate this thing. This is the first case. Similarly, if suppose x is equal to some phi y is given, x is equal to some phi y is given, and y from c less than y less than equal to d. In that case, what you need to do? You put x is equal to phi y, like in that case it will be from c to d f of phi y y dy. Similarly, accordingly you need to change, and dy will be in that case,
Phi dash
dx
y
will be in
dy.
that case phi dash y dy, phi dash y dy plus g of phi y y like this. I have to write this thing, or you will be able to write. Not you don't think like this. It will be easy. We will be, when we will be solving some problem. Suppose, let me take one problem now. Okay, let me take one problem now. Suppose this problem, consider what you have to find. Okay, before going to that, let me. This is two format, and sometimes, so this is case 2 here we have discussed. Now case 3, sometime the curve may be given like this: x square plus y square is equal to 1. Maybe some parametric representation: x is equal to some xt, y is equal to some yt from a less than equal to t less than equal to b, like this may be given. In that case, what you need to do? You can find dx is equal to x dash dt, dy is equal to y dash dt. and put x of t, y of t over here. So in that case, it will be integration over c f dx f dx plus g dy is equal to f dx plus g dy is equal to integration t is from a to b, so I'm writing a to b, then f of xt yt x dash t dt plus g of xt yt y dash t dt. You can solve like this. If some h into dz is given, in that case accordingly some z will be given to you here. You can accordingly change this. Okay, so let me do the problem. Suppose this integrate. So first of all, you judge the curve. What you need to do? You need to define what is this c along which you need to integrate, along which you need to integrate with respect to x here and with respect to y here, but along the curve c. So what is the curve c? C is given the parabolic arc y square is equal to x. This is the parabolic arc. Why it is in parabolic arc? Because from origin to the end of the lattice rectum. So let me plot. So plot the curve first in xy plane. That is most important. So what is y square is equal to x? How it looks like? Y square is equal to, you can write 4 into 1 by 4x. 4, this is a parabola. Y square is equal to 4x. So x axis, and I'm writing x axis like this, and from origin to the end of the lattice rectum. So curve from origin to the end of the lattice rectum. You can take either this side or this side. So end of the lattice rectum means, suppose the focus is here somewhere. Yes, that is equal to 1 by 4 0. End of this lattice rectum means here. So what will the coordinate of this point? This will be 1 by 4. X is equal to 1 by 4. So if x is equal to 1 by 4, so y is equal to plus minus 1 by 2. That is, if I take plus side, so 1 by 2, 1 by 4, 1 by 2. So what is the curve given? C curve is this curve. This is your C. So you have to integrate along this curve C. You have to integrate along this curve C. Okay. So if this curve varies from this thing, so y square is equal to x is given, so you can write x is equal to y square. So what we will do here, we write integration c. So if we project this x is equal to y square, if I write, so in that case x varies from 0 to 1 by 4. Project this here, so 0 to 1 by 4. So x varies, I'm converting all to x. 0 to 1 by 4, it is running from 0 to 1 by 4. Sorry, not 0 to 1 by 4. Let me write here first. I will come back to the range later. So what you need to do here, you put x is equal to y square. So x is equal to y square. This will be y to the power 4 into y. D of x is equal to 2y dy plus, here we have only 2y dy. So you see, you are integrating with respect to y. All are integrating with respect to y. So we'll project in y axis this thing. So as this curve goes, so along this y, what is the change? So this will be from 0
1 by
to,
2.
from here 1 by 2. So the range will be from 0 to 1 by 2. Okay. So this will be now 0 to 1 by 2. Now it is it will be 2y to the power 6, 2y to the power 6 plus 2y dy. Now you need to just integrate this thing. I think you'll be able to integrate this one. So what will the value? 2 by 7.
Y
I
to
can
power
write 2 by 7 y to
plus
the power 7 plus y
yes sir, y
square
square.
0 to 1 by 2. Okay, so put these values. I have taken a complicated calculation. 1 by 2 to the power 7 plus 1 by 4. So if you calculate whatever the value you will get, that is the integration value.
But sir, we can do
So you
from the
can
x in
do this problem.
sir, we can do this
Bolo.
from the x term.
You can do this also from x. That is my point. You can write in that case that will be x is equal to plus minus y. So I suggest you don't if it is given x equal to y square, so add it with this x equal to y square form, because in that case maybe you have to take from minus y to y
Okay.
integration term.
Okay.
So another thing you can do, you can take some parametric differentiation. You see, y square is equal to x. How can we represent in parametric form? I can write
80
x
square
is
and
equal to,
280.
suppose if we choose y is
80
equal
square common.
80 square and 280, or you can choose here. I am simply writing. I am taking from here. I don't want to remember this parametric form. I simply write here y is equal to t. Okay, so x is equal to t square. So t square t, and t runs from, what is the range of t? You see, when from 0 0. So when it is 0 0, in that case t is equal to 0. When it is 1 by 4 1 by 2, 1 by 4 1 by 2, so x is equal to what? In that case 1 by 2. So t ranges from 0 to 1 by 2. So what we will do here now, dx is equal to dx is equal to 2t dt, and dy is equal to dt simply. So it is converted to now. So integration, we have integration what? X square y dx plus 2y dy. So here you put t is equal to from 0 to 1 by 2, x square is equal to what we have chosen, x square is equal to t square, not t square, or what? Yes, x is equal to t square. So x is equal to t square, this will be t to the power 4 into t, this will be dx is equal to 2t dt plus 2t dt. Here coming the same thing, so you can integrate like this
Okay,
from
sir.
here.
Okay.
Okay, fine. Similarly,
हेलो सर
similarly here, हाँ बोलो
सर आपने ओरिजिन से पॉजिटिव साइड ही क्यों
बोल।
लिया? सर आपने 0 से 1/2 ही क्यों लिया? सर 0 से -1/2 भी ले सकते हैं, या फिर -1/2 से 0।
हाँ, यहाँ से लिखा है प्रॉब्लम में क्या लिखा है? प्रॉब्लम में लिखा है फ्रॉम द ओरिजिन टू द एंड ऑफ द लेटेस्ट रेक्टम. देखो, ओरिजिन से एंड ऑफ द लेटेस्ट रेक्टम इधर इस साइड जा सकते हो और इस साइड जा सकते हो. यहाँ पे क्लियरली नहीं लिखा है कौन सा साइड में होगा. इस तरह का नहीं होगा कि 0 to 1/2 जाओ, फिर यहाँ पे आओ, फिर यहाँ पे जाओ. इस तरह का नहीं होगा. ये एक्चुअली मीन करना चाहता है ओरिजिन टू एंड पॉइंट. एंड पॉइंट मीन्स आइदर फ्रॉम दिस साइड, आई एम टेकिंग दिस साइड, और नेगेटिव
तो
साइड.
दोनों का एरिया तो सेम ही होगा ना, दोनों का
नेगेटिव साइड
इंटीग्रेशन
लेने
सेम.
से, हाँ, जस्ट ओरिएंटेशन चेंज होगा. नेगेटिव साइन एक आया.
So that means the answer will be then multiplied
Negative
by
sign
2. Then we have to multiply the answer with 2. So the double will be the correct answer then.
No.
No,
No, it's from origin,
no,
right?
not. You see,
सर वो एक नेगेटिव आएगा, एक
हाँ, it
पॉजिटिव
is
आएगा।
written इस नहीं, वो आने दो, नेगेटिव पॉजिटिव आने दो, पर ये यहाँ पे C को सिर्फ रिप्रेजेंट किया है क्या? C इज द पैराबोलिक आर्क फ्रॉम द ओरिजिन टू द एंड पॉइंट. तो ओरिजिन से एंड पॉइंट तक है. दो साइड में मतलब यहाँ का मीनिंग क्या समझ में आ रहा है? मुझे तो यही समझ में आ रहा है कि ऑरिजिन से
सर वो
कोई एक
आर्क
पॉइंट
बोला है ना, सेमी सर्कल बोला होता तो
सर वो
नीचे का
आर्क
साइड
है इसीलिए एक ही तरफ होगा।
आर्क है इसीलिए तो वो बोला।
एक एंड पॉइंट के लिए
एक ही
एक
तरफ
एंड
होगा।
पॉइंट के लिए
हाँ,
होगा इसीलिए।
इसलिए ये अगर मतलब ऐसा बोला जाता कि इज द कर्व फ्रॉम द हियर एंड टू हियर एंड दिस एंड वन एंड टू अनदर एंड इन दैट केस फ्रॉम हियर टू हियर दैट विल बी द कर्व। ये कर्व से सी कर्व को क्या है वो फाइंड करना। व्हाट इज द सी कर्व हियर that we have just here we are obtaining from here.
But sir, here it is written that to the end of the lattice rectum. So we don't understand that there are the two ends of the lattice rectum. So actually it is singular.
हाँ, टू एंड वही तो बोल रहा हूँ मैं।
So
दोनों
it
में
is
आंसर
writing
सेम आएगा
only
ना,
one
ओरिजिन
end.
से
Yes, yes.
ओरिजिन से वन एंड तक है, तो दोनों में
नहीं
आंसर
प्रॉब्लम
सेम आएगा ना।
माइनस 1/2
तो
हाँ,
-1/2 to 0
कोई भी एक एंड तक, कोई भी एक एंड तक, मतलब इसका लैंग्वेज ठीक से नहीं दिया है। जहाँ से मैं प्रॉब्लम लिया लैंग्वेज सही ढंग से मतलब ठीक ही दिया है।
सर आपको
फ्रॉम
according
वन
to
एंड
language,
उसके
it
मतलब
will be
ये
both
लिखा
sides.
रहता है to the ends of the lattice rectum. Then it said that to the ends of the rectum.
हाँ, ends of the letter rectum. One here if I write one end,
No need to write
it
one
will
end.
be okay. Will it be okay?
It is actually it is showing.
Understand concept, not the
ठीक है,
language.
यही सही होगा।
Sir, no need of one because if there is arc, which means only one side.
No sir,
Then
arc
why?
doesn't
कौन
mean
सा
one side.
एक्सप्लेन ऐसे होता है? आर्क मतलब ओनली वन साइड
Yes, no side.
नहीं नहीं, ओनली वन साइड मतलब इस साइड भी ले सकते हो, इस साइड भी ले सकते
किसी
हो।
एक साइड।
Both side.
आर्क मीन इस साइड भी ले सकते हो, एक साइड भी ले सकते हो, बोथ साइड को नहीं ले, क्योंकि बोला है जीरो ऑरिजिन से वन एंड तक, ऑरिजिन से एंड तक।
And sir,
ठीक है,
सर सी
हाँ,
द
I have
we'll think
asked the
about
previous slides, the previous. So once you said that the delta equals to max of delta S1, delta S2, dot dot dot. So what does that mean actually?
हाँ मैक्सिमम देखो, मैं लेंथ इक्वल नहीं लिया है यहाँ पे। लेट मी गो टू दैट स्लाइड। यहाँ पे मैंने इक्वल नहीं लिया, मतलब डेल्टा ए सर, डेल्टा एस इज इक्वल टू व्हाट, दिस डिस्टेंस दिस डिस्टेंस दिस लेंथ लाइक दिस, सो मेनी लेंथ्स आर देयर। ठीक है, तो किसी तो मैं डिस्टेंस को इक्वल नहीं लिया। ओके, the distance is not equal. In that case, I am defining a delta which is maximum, and length means always positive, it will be. So maximum of delta S1, delta S2 like this. Maximum of delta S1, delta S2 means what? If maximum is tending to 0, that means all are tending to 0. Actually, we are meaning here that all delta S1, delta S2, delta S3 are tending to 0.
Okay, okay.
ठीक है, मैक्सिमम को मैं 0 तब ले रहा हूँ, मतलब तो सभी जाएगा ना 0 की तरफ, इसलिए ऐसा डिफाइन किया गया।
Yes, sir. So see, you just said that so this is line
sir.
integral means we are integrating along the curve, but so ultimately we are again coming back to the x and y coordinates. And I don't understand. So that means that at the end we are ultimately integrating along the x or along the y, but still you are saying that we are integrating along the path.
हाँ, थिंक हाँ, यहाँ पे क्या हो रहा है, समटाइम्स ये क्या हो रहा है, सॉरी फॉर द डिस्टर्बेंस। A tab is not working, why? हाँ ठीक है, सो देखो यहाँ पे क्या हो रहा है, लाइन सिंपल ए टू बी इंटीग्रेशन में एफ ऑफ एक्स का इंटीग्रेट करता हूँ ना, एक फंक्शन दिया रहता है एफ ऑफ एक्स जी एक्स, जिसको मैं इंटीग्रेट किया। यहाँ पे क्या होगा, इंटीग्रेट मैं एफ ऑफ एक्स को नहीं कर रहा हूँ, मैं यहाँ पे एफ ऑफ एक्स वाई इंटीग्रेट कर रहा हूँ, मतलब सरफेस के ऊपर, ये सरफेस है, इसको इंटीग्रेट कर रहा हूँ, इस सरफेस के ऊपर इंटीग्रेशन हो रहा है। तो इन दैट केस क्या हो रहा है, यहाँ पे along the line, along the curve C. So what we are doing actually, we are projecting this C curve either on x-axis or on y-axis, and corresponding points this that will be projected over here corresponding x-axis. So you will get another curve here, another curve like here, and then we are finding this area.
Sir, please explain this part
suppose
once
we are
again,
asked
sir.
to
I don't understand.
see, can you see my pointer? Can you see my pointer?
Yes, sir.
Yes, sir.
Pointer
No,
over
sir.
so
No, sir.
if
Yes, sir. Yes,
Yes,
sir.
sir.
along this curve,
Yes, sir. Yes, sir.
Yes, sir.
okay,
Yes,
okay,
sir. Yes, sir.
ठीक है 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 along this curve C, we are integrating along this curve. Means what? Means we are writing here ds. We are writing here ds along this curve, means we are writing here ds. Okay, so ds is actually this arc length. So we are finding actually this value. Means this value actually what? This value actually area of this one, this thing, a surface area of this surface, surface area of this surface. Okay, now if it is given integrate along f of x, so integrate the curve, these two are different. Integrate the curve C, sorry, integrate f of xy with respect to x. Integrate f of xy with respect to x. I'm writing here with respect to x. So if you integrate with respect to x, that means along this curve C. So with respect to x, so that's why I have to convert it to x term in terms of x. So that's why you are projecting this curve over here on x-axis. On x-axis. So it will be, so if we project here, so there will be range, integration range over here, and corresponding curve, this curve is projected over this surface along this x-axis. We are projecting this surface, so this curve on this surface along this x-axis. So you will be getting another curve over here. Then we are finding this area. So this CF of xy dx means the area of this portion. Simply if I write over f of x integration f of x dx, in that case f of x will be some curve here, and we are integrating this. But here we are integrating over the surface. Integrand is in whatever, when we have a single variable f of x, then we are integrand, in that case integrand is a single valued function, single variable function f of x. But here the integrand is the surface f of xy or f of xyz. When you project this in vector analysis, there you can see, there you can generalize this as fdr, like this vector. We'll do later on that part.
Sir.
Sir.
Okay.
Means sorry.
Now I have to stop actually.
Sir, means integration of f of xy dx plus integration of f of xy dy, is it equal to integration of f of xy ds? Sir, means integration of f of xy dx plus integration of xy dy, is it equal to integration of xy ds?
Let me
yes, sir.
write your
Integration of
point. Integration of
f xy dx
f of xy
plus integration of f xy dy
xy dy.
Is it equal to integration of f xy ds?
No, I'm not saying this. Not like this. xy ds. No. ds is arc length, this arc length. ds is this arc length. Okay, I will discuss this thing. ds I will discuss in next class that ds sometimes you can write in this ds square is equal to dx square plus dy square. Dx square is equal to dx square plus dy square. That thing you can write. In that case, ds by dx whole square will be equal to 1 plus dy by ds whole square. These things actually will do in vector calculus. I'm not would like to introduce this thing here. So, but simply that's why I'm simply writing that integral part only, integration part. So ds square you can write dx square plus dy square, not this thing. Okay, this is not correct. This is not correct. For the time being, you remember this is not correct.
Sir,
Okay, sir. Okay, sir.
sir,
Okay.
why is it
हाँ बोलो
called
बोलो
line
बोलो
integration? Why is it not called arc or something like curve integration? We are integrating it along the curve, not line, I think.
But it is projected on the line. But it is projected on the line.
let no 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 no. What do you mean by line? Tell me.
Line.
Line and curve both are same thing.
Okay, sir.
Line means not a straight line.
Your concept is line. In line not means the straight line. Line not in the straight line. Straight line is
The tilted line is a curve only, sir.
अलग हो रहा है ना?
Tilted line is a
हाँ?
curve only.
Line
No,
may be curved or
Curve is
straight.
a
line
type
and
of
curve
line.
both are same.
Curve is a type of line.
This what you see, what you say. This is if someone is saying this is a line or this is a curve.
So first it is a line, then it is a curve.
Sir.
Yes, sir.
Line and
Line
curve
and curve,
both
yes, sir.
same
Understood.
thing. And if I write the straight line, draw a straight line, this is straight line.
And sir,
Okay.
so ultimately we are doing that
बोलो.
integration on the x and z axis. I mean xz plane we are doing the
Integration?
ultimately calculation.
I'm not getting.
And sir,
Repeat once again.
you told that the line should be projected on the x axis. And
Sometimes maybe on x-axis depending upon.
and then sir,
बोलो.
the curve on the z equal to f of x comma y, that surface, I mean the projected part of the curve on the surface, and that we have also taken, I mean we also need to take the projection of that curve to on again axis,
On the surface
and towards the x axis.
on the surface towards x-axis.
This ultimately it is happening. So see, I mean, in this case, the integration is taking place on the xz plane.
Taking place on the xz plane. Yes.
Yes, sir. That's why I was asking.
Sir, with the
Okay.
help of line integral, we can calculate surface area.
With the help of line integral, I will discuss this thing. You see, I need to stop here now. Just this point, you see, integration a to b f of x dx. What does it mean? Area, na?
Yes, sir.
If I write f of x equal to 1, then what does it mean? Integration a to b dx. What does it mean?
Constant function.
No, what is it
It's the
geometrically mean?
length of a line.
Length of the line. So if I write c ds along the curve, s is the arc length of this curve.
Volume.
S is the arc length of this curve. Then this one is what?
The length of the curve.
Volume?
The length of the curve.
Length of the curve. Yes. Length of the curve. Then this c f of xy ds if I write, then not saying
area
anything.
of the
Area or length. You are I'm not this area of this what I have just discussed this
Yes,
surface.
I mean on the XZ plane.
Area of the arc.
That means you need to find this z is equal to f of xy on this surface, and there you will get one surface here, this one, area of this surface. Now when we'll come back to double integral and triple integral, discuss this thing again. Okay, there we can again find the surface using double
Okay,
integral
sir.
also. ठीक है, तो आज यहीं तक खत्म